So a lot of this you already know. So here we go. It says, I think you guys already know what's up when it comes to properties of sine, cosine, and tangent. Let's chat about the reciprocals of those. So you kind of already know because we did it in like notes 2, I think. Sine, cosine, tangent, and the reciprocal of sine is cosecant, and the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. When I say reciprocal, I mean this. So cosecant theta is equal to 1 over sine theta. That's the reciprocal. So secant theta is equal to 1 over cosine theta, and cotangent theta is equal to 1 over tan theta. Of course, that means the same thing can be said about the other ones, right? You can say sine theta is equal to 1 over cosecant theta. So they're just reciprocals of each other. So, and if you wanted to, you could say cosine theta equals 1 over secant theta, and tan theta is equal to 1 over cotan theta. Nothing crazy, reciprocal properties. How do we feel so far? Not bad, right? Nothing crazy? Okay. Let's see. And then I put here, let's chat about the 6 trig properties with respect to the unit circle. So let's draw the unit circle real quick, just quadrant 1. So here's quadrant 1. And I'm not going to label anything like your coordinates, not until the next page. So here's some ray or my hypotenuse or radius. Remember the radius is 1 because it's a 1 unit circle. So 1. And I have some x and I have some y. And if I draw a vertical displacement, so this horizontal displacement is x, this vertical displacement is y. And if I call this theta, then from there we said, I guess you can write the acronym SOHCAHTOA. And then from there we said that sine theta is equal to y divided by 1, which is just y. And we said that cosine theta is equal to adjacent over hypotenuse, which is just x. X divided by 1 is just x. And we said that tangent theta is equal to opposite over adjacent, which is y over x. So if that's true, then that means that cosecant theta is equal to 1 over y. It means that secant theta is equal to 1 over x. And it means that cotangent theta is equal to x over y. All this we already know, I hope, at some level. Right, guys? Okay. All right, so here we go. Go ahead and turn the page, guys. So I'm just going to focus on the first half of the unit circle. So, yeah, she asked, so we're good. Bam. So I'm trying to focus on just on the first half of the unit circle. And we know that this coordinate is 1, 0. And I didn't draw it perfect. 0, 1. And then negative 1, 0. And then I'm going to try to kind of do it perfect, but yeah, it's all messed up. All right, so I'm going to go, let's see, this one's 30 degrees, 45 degrees, 60 degrees, 90 degrees. This one should be 120, 135, 150, and then 180. That's in degrees, right? And then 0 degrees here. Now what about radians? 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. What about coordinates? Square root of 3 over 2 comma half, that's at 30 degrees. Square root of 2 over 2 comma square root of 2 over 2. 1/2 comma square root of 3 over 2. And then I'm at 2 pi over 3, so that's going to be a negative 1/2 comma square root of 3 over 2. And then at 135, that's going to be negative square root of 2 over 2 comma square root of 2 over 2. And then at 150, that's going to be negative square root of 3 over 2 comma 1/2. And then finally negative 1, 0. put a little happy face. What does that look like? Okay. Here we go. Are we okay so far, guys, or no? Nothing crazy, right? All right, so let's see. It says, find the exact values of the 6 trigonometric functions of 60 degrees. So you already know this. So they want all of them, all 6 of them for 60 degrees. So I'm going to write cosine 60 degrees. I'm going to write sine. Make sure to put the degree symbol, guys. Sine 60 degrees, tan 60 degrees, equals. And I'm going to write, on the side, I'm going to write secant of 60 degrees, cosecant of 60 degrees, and cotangent of 60 degrees. Remember that cosine of 60, cosine is the, it says up here, cosine is the x value. So I go to 60 degrees and the x value is, yeah, 1/2. Not everyone at the same time. Then I go to 60 degrees again and I look for the sine value, sine of 60. Sine is the y value, so I'm going to type, or I'm going to write, yeah, square root of 3 over 2. And then for tan 60, some of you did this on the unit circle quiz, which is fine. I put okay. Tan is y divided by x, so the y value, square root of 3 over 2 divided by 1/2. And some of you left it like that, and I put the word okay because you're not wrong. And then I just put the awkward emoji. The 2's cancel out, and this is just square root of 3. This is the best one. Yay or nay? Perfect. And then secant of 60. Secant's a reciprocal of 1/2. There's at least one of you that did this, and you weren't wrong. And I put okay, and then I put an awkward emoji again. You're right, but I feel like you're a little robotic. That 1 over whatever means reciprocal. So 1/2 goes into 1 twice, but you don't have to. That's way too much work. Just take the reciprocal of 1/2. 2. And that's the best answer. Cosecant's the reciprocal of sine. 2 over square root of 3. You can actually leave it like that unless I tell you otherwise. If you don't see rationalize, you can leave it like that, guys. Let's rationalize it. Multiply by square root of 3 over square root of 3. Just so you guys can know the right answer, right? 2 square root of 3 over 3. If you take your UH quiz online, or UH is going to say 2/3 with a square root of 3 on the side. Same thing, guys. Cotangent, you can write it as 1 over square root of 3. If you rationalize that, multiply by square root of 3 over square root of 3, you're going to get, square root of 3 over 3. UH will write it as 1/3 with a square root of 3 on the side. It's the same. Cool or not cool? Yeah, UH also does this. Like, instead of writing pi over 6, they write 1/6 of pi. I'm not a fan of that. I prefer just writing pi over 6, but 1/6 of pi is the same. So don't freak out when you take your UH quiz. All right, here we go. Cool or not cool, guys? All right, so now let's look at the 180 degree, guys. We're doing the same thing. Cosine 180 degrees, sine 180 degrees, tan 180 degrees, and then secant of 180 degrees, and then cosecant of 180 degrees, and then cotangent. All right, let's do the sine, cosine, tangent first. Cosine is the x value. I go to 180, and the x value is -1. Sine is the y value. I look at the y value of 180, and that is 0. Tangent is y divided by x. 0 divided by -1. I guess that's fine. I'll just give an awkward emoji, but the better answer is just 0. Cool or not cool? Cool. And then secant of 180 is the reciprocal of cosine. The reciprocal of -1 is -1. It's itself. Does 0 have a reciprocal? No. Undefined. You can also say no solution. Cotangent of 180 degrees. Well, again, 0 does not have a reciprocal. So what do we write? Undefined. And that's it. What do you guys think? Not bad, right? You guys doing okay, guys? Or is it too early for you guys? It's never too early to do math. You just gotta listen. Do you guys hype yourself up in the morning by listening to like hard rock music, like ah? Yeah, you should. It's okay. Sorry, some of you guys make me laugh because you guys are like not interested. Like it's too early. I wish I had a button that when I pushed it, fire would just. Yeah. All right, here we go. Here we go. I'm sorry for distracting you guys. It says the terminal side of an angle theta contains a point -5, 2. So that means that the ray has that point. Find the exact values of the 6 trigonometric functions of theta. Use radicals, no decimals. All right, so here's my grid. -5, 2 is quadrant 2. So I'm going to exaggerate quadrant 2, guys. So there's my quadrant 2. And I'm going to say -5, 2 is like right there. Yeah, -5, go to the left, and then up 2. So from the origin, connect those 2 points. That's going to be your radius or your hypotenuse. And then bring a line down perpendicular to the x-axis. It's always, this is called your reference triangle. You always have a perpendicular to the x-axis. The angle they're talking about is this one right here. That's the angle they're talking about. I'm going to slow down. Notice that if I look at this angle and I say, what's opposite? You're like, I don't know. It doesn't ever close. So we use our reference to help us out. So this one that I'm putting in sky blue is the one that I'm using to help us out. That's our reference angle. Are we okay? Okay, so this is why the reference angle is so useful. So now that I know that, I'm going to write everything in sky blue here. This x displacement is -5. This vertical displacement is 2. I need the hypotenuse. You can also call it the radius because it's kind of like the radius of a giant circle here like that. So I need the hypotenuse. So how do I get the hypotenuse? I just do this, square root, and I put -5 in parentheses, square it. You do that when you put it in the calculator as well. And then you square the 2. Negative times a negative is a positive, so I'm going to have 25 plus 2 squared is 4. I'm going to leave it as the square root of 29 because it doesn't break down to a nice pretty number. So square root of 29 is my hypotenuse. Are we okay? Nothing crazy. I write the acronym SOHCAHTOA unless you already feel like you're a beast. SOHCAHTOA. You don't have to write this all the time. If you're already a beast, then don't worry. Don't write it down. And I'm going to start with sine. I'm going to write sine of this angle, which is really, remember, we're using the reference to help us out, but it really is this one right here. Sine of that angle is opposite over hypotenuse. Opposite, use the reference to help you out. What's opposite? 2 over hypotenuse, square root of 29. Does it tell me to rationalize it? No, I'm going to leave it like that. Cool or not cool? Cool. I go to cosine. Cosine of that angle. Cosine is adjacent over hypotenuse. I go to my reference to help me out. What's adjacent? -5 over. Perfect. I'm going to leave it like that. I'm not going to rationalize it. I'm going to put tan. Tan is opposite over adjacent, so I'm going to write 2 over. And you can put the negative in the front. I had a professor who, I never kept his habit, but he would always tell me to put the negative in the front like that. It doesn't matter, guys. Put the negative wherever you feel. This is America. That was a joke, but it wasn't very funny. All right, so there it is. And now I'm going to do my 3 reciprocals. So here we go. I'm going to start with sine first. The reciprocal of sine is cosecant. And that is going to be square root of 29 over 2. The reciprocal of cosine is called secant, and that is going to be 5. I put the negative in the front like that professor told me. And then the tangent, the reciprocal of tangent is cotangent, and I'm going to write, there you go. And there it is, all 6 of them. Do we feel okay? Yeah. All right, let's go to the next question. And it says, oh, ask, guys, ask, because I can't read mine. Okay, this one says, if an angle theta terminates in quadrant 4, so they're already telling me what cosine is, find the exact values of the other 5 trig functions. So I'm in quadrant 4, so let's exaggerate quadrant 4. So there it is, I'm exaggerating quadrant 4. And they don't tell me a point. This time they tell me cosine is 3/5. So here's what I do. I pick a point. I pick a point. It's not to scale. I'm going to connect it to that, and I'm going to do it perpendicular to the x-axis like that. The actual theta is this one. But I'm going to use the reference to help us out. Theta r. Now remember, cosine is adjacent over hypotenuse, so it's a horizontal displacement that is 3, and the hypotenuse that is 5. By the way, and I'll slow down, the hypotenuse is never negative. The hypotenuse is never negative. It acts like a radius. All right, I need this distance here. I'm going to call it y because it's some y value. So I'm going to go 3 squared plus y squared equals 5 squared. And I know some of you already know that that's a 3, 4, 5 triangle, but just in case, y squared equals 5 squared minus 3 squared. I just moved that 3 squared to the other side. So y equals the square root. 5 squared is 25. 3 squared is 9. So that's the square root of 16. So the square root of 16 is 4. Now, before you go putting in a 4 here, I'm in quadrant 4. And in quadrant 4, the y values are negative. So put in there for good notes, negative since y values in quadrant 4 are negative. Oh, man. All right. I got everything I need. Here we go. Cosine. Cosine of that angle. It was given 3/5, but you could also have gotten it from the graph. Sine. Sine is opposite over hypotenuse. Let the reference help you out. What's opposite? Perfect. Negative 4 over 5. Tangent. Tangent is opposite over adjacent. Perfect. And that's it. I'm just going to do the reciprocals for the others. I'm going to write secant. Secant is 5/3, and I guess you can put given, kind of, right, if you wanted to. Cosecant, CSC. What's that? And then finally, cotangent. That's a 3/4 there. Negative 3/4. How do we feel? Not bad, right? Yes. Oh, just stretching. Sorry. I thought you were asking a question because you had your. But you were. You had a question? Oh. Tricksters, man, tricksters. All right, here we go. Don't worry. Is this the last one? Oh, look, guys, this is the last one. We're like so way ahead of schedule. If an angle theta terminates in quadrant 1 and cosecant is 13 over 12. Now, if cosecant is 13 over 12, that means that sine is 12 over 13. Find the exact values of the other 5 trig functions. Okay, I'm going to exaggerate quadrant 1. It doesn't have to be perfect. I'm going to put a point. It's actually not perfect. This is my angle. That's also your reference as well, because you're in quadrant 1, but that's fine. Opposite is 12. Hypotenuse is 13. Are we still okay? I'm going to call this x, because that's what that is, the horizontal displacement. And I'm going to go x squared plus 12 squared equals 13 squared. So I'm going to move the 12 squared to the other side. X squared equals 13 squared minus 12 squared. X squared equals, I want to say 13 squared is 169. And I want to say 12 squared is 144. My memory sometimes is bad, but I want to say those are accurate.
144 is accurate.
Yeah, I think the 169 is accurate too. So x squared equals 44, 54, 64, 69, 25. So x, the square root equals 5. And I know some of you probably remember this from geometry. That's one of the special ones, a 5, 12, 13, but no big deal if you don't remember. And here we go. You guys ready? Sine, or I guess sine was already given, well, kind of. I'll write it anyway. Sine theta equals 12 over 13, and I'm going to write given, comma, kind of. Did I spell it right? I was going to write kind of, K-I-N-D-A, but I was like, I better not, kind of. Cosine. Cosine is adjacent over hypotenuse, so that's going to be Perfect. And then I need cotangent. Oh, let me write tangent first because that's how we've been doing it. So let's not go out of order. Tangent is opposite over adjacent, which is, all right. And now I'm just going to take the reciprocals. The cosecant is already given. 13 over 12. That one was given for sure. And then secant is just the reciprocal of cosine, which is, and then finally cotangent is the reciprocal of tangent, which is, what do you guys think? Yeah. So now let me pass out an activity.
Bro, that was crazy. Good job. What is this? And nice.
Don't get me wrong, I like Delta Math, but I noticed that with Delta class, we did yesterday, and while they get it, but they're bad with their writing stuff. So I concluded yesterday or 2 days ago that we were writing.
No, but the one about the baby.
We'll be adding a Delta Math, but not right now.
It's like how
No,
the
we're gonna- No, man, it's yours. I have read it.
So are you
I have been eyeing stuff, but I have read it.
No, you have videos like with me and my friend came up and we're like, why is this pen? No, I didn't. But then the guys that are like, no, I didn't think of like, yeah, you're the one who's the guys are like, oh, you're just someone who thinks everything wants to be.
Did everyone grab an activity? Alright, so I will do one question for you. So let's go to the activity together. Okay. I kind of feel like doing 1, 2, 3, or 4. I kind of feel like doing number 4. Can I do number 4? Alright, number 4. Go to number 4. It says, what are the instructions? It says, find the exact values, no decimals, of the 6 trigonometric functions of an angle theta in standard position whose terminal side contains a given point. So I have a point, 2, 3, so I'm going to exaggerate quadrant 1. So here's me exaggerating quadrant 1. And then I have the point 2, 3. So I'm going to go 2 to the right, 3 up, and put a point to scale. From the origin, connect those points, and then draw perpendicular to the x-axis. So that means the horizontal displacement is 2, and the vertical displacement is 3. Continuing, here's my hypotenuse. Square root of 2 squared plus 3 squared. So that's going to be, let's see, 2 squared is 4, 3 squared is 9, so the square root of 13. So that's the square root of 13. All right, here we go. This is my theta. I'm going to write cosine theta. Cosine is adjacent over hypotenuse, so I'm just going to write it as 2 over square root of 13. It does not tell me to rationalize, so I'm going to leave it alone. Unless I put it to rationalize. Nope, I didn't. I'm going to write sine theta. Sine is opposite over hypotenuse, so 3 over square root of 13. And then tangent. Tangent is opposite over adjacent, so 3 over 2. Let's see, what else? Secant. So secant is a reciprocal of cosine, so square root of 13 over 2. And then cosecant. Cosecant is the reciprocal of sine, so square root of 13 over 3. And then finally cotangent. 2 over 3. How do we feel? All right. 5 through 8. Okay, look at question number 8. This one is in the notes, the exact question. Rewrite it. That one is this one. Look. That one is this one right here. Terminates in quadrant 1. Cosecant is 13 over 12. And that one says terminates in quadrant 1. Cosecant is 13 over 12. So just rewrite it, put it back in there. So I'm not going to do any of those because of that. And then this one, find the exact values of the 6 trigonometric functions. This one is in the notes. rewrite it in here. And I thought I'll put one other, and this one is in the notes. Look at all those questions that are already answered for you. Don't just leave it in notes, write them out, put it in here. Cool or not cool? All right, guys, we have an hour. I think that's more than enough time to finish this. So turn this in today, please, and then just work on your UH trig, and that's it. Good job, guys.